the very first problem that we're going to solve. Now, I will be solving each one of these problems as thoroughly as I can, walking you through each and every step. And so let's first get a sense for what this problem is all about. Let's take a look. I want to show you some hard problems that show up in pandas that go beyond just single column analyses, which oftentimes I think are the bulk of what people talk about in pandas, but not really that interesting, or growling or group by analyses, which again, there's some interesting things there, and we will talk about that at one point, but there's a lot more going on. Here, I'm calling this problem the deltas to state problem. Here's how it works. You have some data set that tells you how something has changed. It tells you the deltas. And from that, you need to figure out how to get the state at any one point in time in order to answer certain questions. Let's take a look. In order to make this a little bit closer to something that might be real, I've borrowed some of the framing of this problem from how we first encountered this problem when we had to solve it ourselves. We're going to imagine that you have to manage some sort of devices. And these are devices that are provisioned, they're put into use, they're deployed before they're put into use, they may go under maintenance, then they may go back into use, and then eventually they're decommissioned. And you have some data store that records when each of these events occurs in the life of the device. On such and such date, it's provisioned. On such and such date, it's deployed. On such and such date, it's under maintenance. Then it goes back into use, and so forth and so on. Not every device is guaranteed to go into deployment. Not every device is guaranteed to be decommissioned for this data set. But what we want to be able to answer are questions like how many devices are deployed but not in use as of some point in time? What is the average amount of time a device was under maintenance? What is the average amount of time between provisioning and deployment? And if you think about it, these two problems are very similar. And which phase of the life cycle has the highest median length? Now, I do not have a pre-written solution to this problem. I'm going to be thinking through this problem and to show you how some of the common concepts that we encounter when we look at any kind of pandas problem are just as applicable to a very complex problem like this. In order to make this problem work, I need a sample data set. And so here you can see the sample data set that I have. I have some devices with their identifiers, and I have their different states that they transition through from provision to deployed, then in use, then under maintenance, then in use, then under maintenance, and the date and time for when each of these events occurred. And I'll show you one or two notes of how I generated this sample data, but I won't go into that in too much depth because we have a lot to discuss for the answer for this problem itself. It's kind of interesting how I went about solving this problem. I thought that what I really wanted to do was simulate a device that might go under a particular life cycle. And so whenever I think of simulations, especially something that has multiple steps and is a closed form, I think generator or coroutine. And so I wrote the simulator as a simple generator here because I thought it makes it really clear what the steps are, how we transition between these. And so this is just a generator that yields what state it's in and what the time delta from some starting point would be for this. And so you can see that somewhere 90 days after whatever the base time is, whatever that epoch time is, it goes into provisioning. Under some probability, it might be deployed. If it is deployed, then it's going to also be decommissioned. In between deployment and decommissioning, it goes through some random number of rounds of being in use, then in maintenance, and in use and in maintenance. And you can see that some of the answers to the questions that I want to solve might even be determined just by how I'm generating this data, but we'll pretend that we don't see the automatic data generation, we don't see the random data generation. And then I'm taking this life cycle and I'm putting it into a pandas data frame off of the tuples that it returns, and then I'm doing a little bit of pandas mechanics, adding in the device name, setting that as the index, doing the cumulative sum of the time deltas, and then adding that to some base time. Here you can see the epoch time, the starting point for everything. And I get my life cycles. I want to take this data, and I want to derive from this data not when was each device provisioned, but what is the state of each device at any point in time. Because somebody could easily say, you know what, how many devices are in maintenance as of some point in time? How many devices are in use as of some point in time? Let's talk a little bit about some of the background and the theory. And the most important theory that we have here is, when we talk about pandas, we are talking about some sort of index-aligned data structure, some sort of one-dimensional data structure where the data has some metadata associated with it, and that metadata is our index. And so if I copy my sample data, or better yet, if I pickle my sample data, we'll make our lives really easy. So we'll say something like this, lifecycles.toPickle. and then I pick that up, I can show you a couple of aspects of this problem that we have to consider before we even get started. So here, we'll pickle our data, and then we'll pull this data in on the other end. And we'll, of course, make sure that we name this consistently. There we go. And, and of course, the one unfortunate thing is because we have this structure here, we'll just have to make sure that we grab this structure and bring it in as well. Otherwise, the pickling, which is not a terrible way to just transfer this data from one place to another, just to make sure that works. So there we go. So here's our data. Now, anytime I look at a data frame, I either ask myself, what is the indexing, and what do I want the indexing to be? And as you look at this data frame, there's actually something kind of interesting here. What constitutes the data and what constitutes the index are not necessarily guaranteed to be unique for any given data set, and in fact is oftentimes determined by the problems you're solving. One thing you can see here that's interesting is, here my indexing is the device and what state I tagged a particular piece of data, the time against this. But you could imagine that for some other analysis, maybe what I might want to do is I might want to actually pull that state out. Let's not drop this. And set the index to be the date itself. And so here, let's take a look, and append equals true, and there we go. And let's make sure that we have that named as well. And here, this is it's actually a series object. Okay. And this is actually called time. So here we go. There we go. And so here you could think, another analysis might actually care about the states. It might ask, for every given entity, for every given device, what was the range of time that was both provisioned and then decommissioned? And we can answer that question very easily from this, where I guess even that, we're still performing a computation on the underlying dates. We're not performing the computation on the underlying states. And so if we wanted to know how many times the device go under maintenance, then you could think the underlying computation is performed on the states. And so then that kind of makes sense if I wanted to ask myself something like, group this by the device, and then for that group, you get each one of these groupings here. So we're going to do a lambda. Let's do an ag with a lambda with the group. And then in that group, just count how many times, for example, let's do something like this, sum1 for x in the group, if this x is equal to, or if this x is literally the state.maintenance, we get something like, how many times did this device go under maintenance? And you can see we're performing the calculation on the state. And the date time, if we wanted to do something like, how many times did it go under maintenance per week, per month, you can see that's part of the index aspect. Well, for this particular analysis that we want to do, it's pretty clear that the calculation that we want to do is going to be based off of, some calculations will be based off of the dates. For example, if we want to know what is the average amount of time that a device was alive for, then you can think the computation is done on the dates, and that would be something a little bit different. Here I'm going to do a group by the underlying device. And then here, for each one of these groups, maybe I will filter this by any group which happens to have both of my provisioned and my decommissioned states in it. So here I'd say, let's do something like this, or state.provisioned in a set of these, and state.decommissioned in the set of these. That should work. And by the way, this should be the group here, and this should be the group here. And here, that should work. Let's see what one of these operations gives us. Let's do an ag here instead. Really? And let's see what our group looks like. This will be a group by, it should be the data. Let's do one more thing here. See if that actually makes a difference. These should be, there we go, that's interesting. There's no case where that's the case. Let's do an ag here and see what's going on. Nothing was provisioned. Let's take a look at our data one more time. And let's see, Oh, and we're actually looking at the wrong thing. We're actually looking in the values. We should look in the index. So we should look at the g.index.getLevelValues of the state. There we go. You can see everything that was provisioned, and then we do the same thing for everything that is decommissioned. And that should give us everything that actually went through the whole life cycle. And so you can see, we got to spell everything correctly to get this to work. You can see not everything was provisioned and decommissioned, and then we can switch this to a filter, and then we get all of these groups where it went through the actual life cycle. And then once we do that, we could do another group by the device. And presumably we could make an assumption that the provision was the first time, the decommission was the last time, or we could do some sort of indexed analysis here. We could do something like this, take that group and then do a lock on that group to find when it was provisioned, and then take that result and then compute the minimum of this. Of course, we need to do this on just one of the levels. So here, we might do an index slice and grab everything, because when we do the group by, we'll retain the device as the outer level here. So we might have to do a slice just to get that one. And then you can see here, that's the minimum time for the provisioning. We could find the maximum time for the decommissioning, just in case we're worried that maybe something was double provisioned or double decommissioned. And then to figure out what the difference in those times are, we can just take the subtraction, the difference of these. And you can see we have two analyses that solve two distinct problems. And really how we set this data frame up, or how we set the series object up, what is the index and what is the underlying data, is going to be dependent on what we're actually performing computations on. One of the worst things that we could do is to just make everything a column and then assume that we're just going to do column level operations and eliminate the usefulness of this index and some of the preciseness of the use of this index. And so really the core concept behind this problem is understanding how that index works. And so if I were to take this and try and think about how I'd go about solving the problem, well, I know what I want the end analysis to look like. I want to answer questions like, as of some day, how many devices were in maintenance? So what I know I want to do is I know I want to have some structure that I can group by. And I know I want to group by some sort of time or date aspect, or some computation on that, maybe the time rounded to the nearest week or something like that. I know that within my aggregation here, I want to figure out which devices are in what state. And you know what? If I set this up nicely, I could even do something like this. I could take my data frame, I could look for every state that was maintenance, like this. And then I could group by the entity. And then here you can see I would just have to count those and count the number of times for each one of, and I actually group by the date first. And then here I could do another nested group by. So here, let's do something like this. And then for each one of these groups, I just have to count the unique entities. So this might be something like, index get level values, entity, and then I could drop this into a pandas set, into a Python set, or I could do something like unique or n-unique or something like that. If I have the data frame structured the way I want. And if I think about it that way, then probably what I want this data frame to look like is I want it to be something where I have every date. So I have every date here. I have every entity, like that, for every date. And then I have the state that it's in on that date. But that's not what I started with. I started with the deltas. So I have to figure out how to go from one structure to another, where the original structure looks like this. It looks like the entities themselves and their transitions, and the date when they transitioned, and turn to a structure like this. This latter structure is going to be a lot larger too, because in the original structure, the deltas are fairly few, right? It only is measured every time we see this device go from one state to another. But in the other structure, we're going to have one row for every date and for every entity. And that's the key to the problem. Oftentimes when you're solving problems like this, what you'll see is that this requires either a clever use of index alignment or a clever use of reindexing with the multi-index. What I'm thinking here is, what I really want is I want a multi-index. And I want the multi-index to give me every single entity for every single day that that entity existed. And so I want a multi-index that is constructed from a sequence of arrays. Something like this. I want, and the simplest way I could do this is from the product. So here I do like a multi-index from product, and this would be all the unique entities. And then here I do the product of the unique entities against the unique days. And from that, I could then take my existing data and try and fit it into this data. I could fill in each one of the entries that I have. And if there are gaps, I could just backfill or forward fill. And in fact, that is the key to this answer. Basically, what I want to do is I want to do an index-aware, a multi-index-aware broadcasting on some kind of assignment to give me the resulting data structure and then do some sort of backfilling or forward filling to get the final result. And so, why don't we see if we can come up with an answer for this problem? Let's take a look at the answer. I'll start with my read pickle to read in my data, and that'll give me my series object. And in this series object, of course, I'll also need one more piece. I'll need just my enum, which makes this work. Now, from this, what I want to do is I want to figure out for each individual entity what was the range of the dates that that entity existed. And there's a subtle reason why I might want to do that. When I'm filling in the gaps, one of the problems is going to be that if I fill in the gaps prior to the entity existing, then I might pull, say, the provisioning state a little bit too far into the past, or I might pull that decommissioning state too far into the future. So what I really want is some structure that's indexed on this entity and the starting point and ending point. I know one nice simplification here is I only really care about the underlying days. I don't care about the time of day just yet. And so what I could do is I could first do a dt to period and just get the actual day. Okay, that's good. I could do a group by on this and group by the entity. And there we go. And let's group by the entity, or actually in this case, the device. Like that. Very good. For each one of these, I could figure out what the min and the max time is. That's the minimum max time the device even existed. And so now I know that that gives me the date range for each one of these. I could construct a date range from that. So here, what I could do is an apply operation applied to each one of the rows. And I could create a date range from the minimum and the maximum. And this is going to be a little bit slow. You know, when we do an apply down the rows, that's going to be kind of slow. But one of the reasons why I might accept that is because at this point, I should have one row per unique device. And you can think that as part of any of the additional analysis that I'm going to do group bys on the device level with a UDF, with the user-defined function anyway. So I'm probably paying for the cost of calling a Python function on the scope of the rows no matter what. And so maybe it's not the end of the world for me to do something like this. Now here, we want to apply this on the index axis, I believe. So here, we want something like this. And let's just double check that that gives us the structure that we want. So here, we should have had a series object, or we should have a data frame now with a min and a max column. That's good. And what we can do is, we do want to do an apply here. And maybe I got the axis here wrong. And there we go. And then here, we have a period object. Here, we can just do the lower bound of this thing and the upper bound of this thing. And that should give us our date range. Let's, of course, make sure that we do it like that. Very good. By the way, this is just like that and that. Let's figure out for our period object what that looks like. And so s.dt.toPeriod d. We'll look at one of these. And I'm going to do an I@, to get one of these objects. And then let's see, what's our lower bound? Got to figure out what that API call is, and it should be, oh, start time. Okay. So here we're going to do start time. That gives us the lower bound. Okay, very good. So let's do this from the end time and the start time. Very good. And you can see now we have each one of those date time indices. Pretty nice. Then we probably want to turn this into a multi-index of some sort. So we probably also want to get the rows index value. So what we're going to do is we're going to do a multi-index from product. So we'll do a multi-index from the Cartesian product of these. And maybe doing this within .apply, maybe that's a little bit going too far, because we're going to have a little bit of difficulty pulling this out of the apply. But here we're going to do a row index. We'll just get the 0th element of this, because that should be identical for everything. And then here we go. That should give us our multi-index. Put a comma there. Okay, now you can see why doing the apply is a little bit hokey, a little bit phony baloney. So what we'll do is we'll just make this a pipe operation instead, and we'll operate on the data frame that we have, and we'll make this a comprehension syntax instead with one multi-index for each row. So we'll say for row in df.iterRows. And then here we can actually pull the index. Actually, we can do this. I'll show you another way we can do this. We can do this with another group by. And then that way we can grab the group key out as well, like that. And here, we just have to make sure that we have, I think that actually becomes there and there. Okay, very good. And finally, we have a start time and an end time. Let's see what happens when we do this just on the index object itself. And then here, let's do this like that. And this has to be, yeah, entry like that. Very good. We get a multi-index with here. Let's just put a sample value in there. We get each one of those. Very good. And then let's pull in our date range. And I think that gives us what we want. And then finally, we have to grab the, this is a multiple start time, so this needs to be, for each one of these rows, it needs to be the 0th element. So it's got to be like the iloc of 0, because otherwise this thing is a little bit too big. So you can see there's a little bit of clumsiness we have to work around. But, and then once we get the iloc there, then we get just the actual period object, so we don't need that anymore. And so now we have the right multi-index. Now, of course, we can construct this in a variety of different ways, but you can see we have exactly the indexing that we want. There's one small trick to this. If we try to do a re-index on the original data set and we try and re-index it in this way, it actually turns out to be a little bit slow. I'm going to show you one thing that actually will be surprisingly fast for this. What I'm going to do is I'm going to say, here are my states. I'm going to create a series object, and I'm going to use this as the index of my series object, like that. And I'm going to set the data of the series object to none values, just so that I get a pi object structure. And so you can see, and let's say this should be my index, and here this is each one of those, and so I want to concat these. I actually want to join these together. So what I'm going to do is I'm going to, in order to concat these, that's where it gets a little bit ugly, we're going to create something a little bit different. We're going to create a series here instead. We're going to use this as the data for the series, and we're going to set the index to this, like that. And then we're going to concat these together to get a single series object using pandas concat. And that should give us, there we go. And then here, this needs to be repeated for the size of this thing, but we can do a little trick here. We can make this a data frame instead. And then we can assign into this data frame device equals index, and then set index, like that. And then we'll squeeze it down to a single structure. There we go. And here, we still need our series there. And finally, we want to take a look at this and just make sure that this result is the right index. So there we go. And then finally, it's the squeeze. There's one really unfortunate thing about the squeeze. You have to do squeeze access equals columns. Otherwise, it squeezes into a single value if there's only one row. So there we go. We got our multi-index. Beautiful. We might even store this just to make our lives a little bit easier. Store this as its own value. And then there we go. And now we end up with a structure that looks broadly like what we want to assign into. You can see here, and let's make sure that this index has, and by the way, once we do that, I don't actually think we want to set the index here. I think we want to keep it as it is, and then let it get turned into a multi-index. So here, we'll turn this into a multi-index from, I'll show you a trick, multi-index from arrays. And we can see what we had for this structure. This was a concatenated data frame. And so this should be index device and index, and whatever the name of that would be, which is the date. Ooh, a lot of steps to solving a problem like this. But for the most part, you can see that the mechanics of something like this really come out to be mostly index manipulation, right? And then here, this aspect here, the actual data of the data frame needs to be named as well. So I'll show you a little trick. There we go. There we go. We got a nice multi-index, which means our state structure looks the way we want it to look, and then we can actually do an index-aligned assignment into this, which means we can start with our original data, and we can say that for the index alignment, what we really want is we want that index right now to be the data, and we want the data to be the index. So we're going to take this, we're going to reset the index of the state without dropping it. We're going to set the index for, I think it was called time here, like that. Before we append this in here, we might actually choose to do some rounding so that it matches correctly. So we'll do the 2 period on this before we reset the index. So we'll do a 2 period here, like we did before. And then this should be a dt.2 period. There we go. And then reset index, and then set the index. And now you can see these kind of line up nicely. The order of the levels won't line up. Oh no, the order levels map up. Very good. It's the device first. Very good. And so we should just be able to do this. This is our actual raw data. And we should be able to say data at its index is the values there. And that should, if we got that right, that should fill in everything. Let's take a look at what our data looks like. And just make sure that that matches up. So this is the data index. This is the states index. Very good. That's the device and the time. We better name all of these similarly, just so that we get everything working correctly. Okay, very good. And they should match both in terms of the data type and in terms of the underlying data itself. Very good. And we'll just see where we're missing the index alignment. None of all of those entries are in our index. Let's just double check to see. One trick that we can do just to make this work is we can get this as the intersection of the original index. Let's see if that helps. And so this is states. Okay. Let's see why we just got to look at the indices and just double check to see why they look different, because they shouldn't. So we have every entity, and we have everyone there. Very good. And that's our states. And let's just check the D types of the index. Otherwise, that will cause a... Yep, that's right. And here we go. And you can see, the alignment doesn't quite work if we don't set the D types properly. So here it's expecting there should be something like a floor to get these to line up. There we go. Okay, very good. And then here we go. Let's take a look at what that turned our index into. Yeah, it should be good. Should be named identically, Everything's, let's see what the shape of this thing is and the shape of this thing. One of them should be significantly larger than the other, and of course, this needs to be a .lock operation. Okay, and there we should actually have something working. Here, we're going to assign to each one of those positions data.index. Let's just see why that doesn't work. Okay, very good. That's right. States.index. Almost there. That's right. They're named identically. They have the identical D types. They're both multi-indices. And let's just take one quick look, get level values. Because at time, sometimes if we switch between, no, that's good. And let's see if it's the same thing for this one as well. Time, frequency is set. They're both the same D type. They're okay. And there's one more detail that is slightly different there, but that shouldn't be a big deal. Just the length, because it's truncating how this thing looks. So at this point, this should actually work. The question is why it doesn't work, and see if we can sort this out really quickly. Otherwise, we'll have to move on to our next question. Here, let's just double check. Oh, and then here, that's the last thing. This state here should be not a list of lists, but it should be individual values. So I think we need to take a look at the data and, yeah, and let's do something D types. Let's see what the D type is. Let's see what one of these objects looks like. Okay, and let's see. Is this a series object or a data frame? Maybe that it's a data frame, and then the index alignment doesn't like that. Yeah, so we got to squeeze this thing as well. And squeeze it just on the columns to make that a data frame, and then crossing our fingers it actually works. And you can see there's a little bit of finickiness just to get pandas to like the alignment. You got to match up the names, you got to match up the D types, you got to make sure that you're doing a series to series alignment. Otherwise, those series to data frame alignment sometimes get you in trouble. So yeah, there's a little bit of work here, but what you can see here is we ended up getting every device, and we managed to index align ourselves to every device, every possible date, and which event. And now all we have to do is we have to do a group by the device and just forward fill. Because if we don't have an update from the last time that we learned something about this, well, that's just keeping whatever the current state is and moving it forward. And we could, of course, do a backwards fill if we had extra things, or we could drop NA if we had extra things. But for the most part, here, we just have to do this last piece once we get the index alignment to work. And now, we actually have a relatively efficient way for ourselves to do something like group by states.index.getLevelValues. We'll do the time. We'll group this by, or we'll do a 2 period. We'll get the month out of this thing. So there we go. And then we'll do a value counts. And as long as, of course, there's one tiny thing we have to do just because we're using this enum. We're going to have to do one small other detail. We're going to make these things orderable. Total ordering, but that's not too hard. We just have to make this thing total orderable like that. And we actually managed to solve this problem from scratch, live coded, without knowing the answer ahead of time. There we go. And we got to make this thing hashable as well. Now, these problems are not hard so much as we just have to make sure that we're aware of them. And then you can see for every day, the total number of devices in every single state produced as a series object. Instead of solving just one problem, how many devices were provisioned, we solved every possible problem. How many devices were in each state. And then what we could do with this is we could then filter this down with an index slice. Here we care about the provisioned devices on every day. So finally, we'll do a lock with an index slice and look for just the devices that are provisioned. And from our delta information, and we'll have to import index slice, we can answer this question. Okay, Let's just double check. Value counts, that's great. Lock, index sliced, state.provisioned, good. And then finally, one more thing we got to do to just make these right. We'll say if is instance other and enum, else false. There we go. And so here you can see the total number of devices that were provisioned for every single month from the deltas. What do we learn from this? Look, pandas is not easy from the perspective of you can just immediately write working code off the top of your head. But what we learn from this is pandas largely is easy from the conceptual perspective because everything orientates itself, everything orbits around indices, index alignment, the construction of indices. There's a lot of small details to get right. For example, you got to make sure things are named properly. You got to make sure that when you're doing index alignment, you're aware of whether it's series against series or data frame against data frame or series against data frame. You have to make sure that the D types work correctly because there's a couple of rough spots around, for example, matching up the period index to the date time index. But all of those are details. You can see once we have the core idea for how to solve this problem, then it really is just a matter of working through the small details in order to be able to get pandas to do what we want it to do, to work around some of the roughness of pandas, to work around some of the remaining roughness of things like the multi-index, but to actually solve a very hard problem in just a couple of lines of code, quite elegantly using pandas itself.